So on Monday we talked about circles. Today we're going to talk about parabolas. What's a parabola? It's a curve. That's true, but lots of things are curves and they're not parabolas. Is it an exponential curve? No, it's not an exponential curve. No, still not. All right, well, I'll give you the classic Greek definition. For a parabola, you have a vertex. So we're going to make our lives a little bit easy. We're going to put our vertex right at the origin. Then you have a point called a focus. So I'm going to put the focus right up here. And you have a line called a directrix. The distance from the vertex to the focus, that distance is traditionally called P. And P is also the distance from the vertex to the directrix. So the vertex is kind of halfway in between the directrix and the focus. And we have a parabola that looks like this. And the rule for the parabola is, if I pick a point anywhere on the parabola, this point right here, let's call it x comma y, the rule is the distance from the focus to that point, so that distance, will always be exactly the same as the distance from that point to the directrix, where that forms a right angle right there. And that's the definition of a parabola. It has that property that the distance from the focus to a point is exactly the same as the distance from the point to the directrix. Questions on that? Okay, using that information, we can come up with an equation. This point that I called the focus right here, what's its x value and y value? The x value is definitely 0 because it's on the axis. How about the y value? Same as the p number, isn't it? Because we said the distance from here to here, we called it p. So this is the p number. So that point is 0 comma p. And then how about this point down here that I'm using to measure the distance to the directrix? What's the x number of that point? It's x. It's the same as the point on the parabola, isn't it? Because that's a vertical line. So that one's x. And what's the y value? The y value would be negative p because this line sits down p units. So the y value here would be negative p. All right, so what we said had to happen is this distance from the focus to this point has to be exactly the same as this distance from this point to the directrix. How do we find the distance between 2 points? We could guess, but more specifically, we would probably use the distance formula. All right, so let's start with, I guess we'll do this one first. The distance from this point, x comma y, to this point, x comma negative p. According to the distance formula, we would take the square root of we would subtract the x numbers, x minus x squared, plus we would subtract the y numbers, y minus negative p squared. So that's this distance. This is the distance from this point, xy, straight down to that point, x negative p. And that has to equal the distance from xy back to the focus. So again, I use my distance formula. That's square root. I subtract the x numbers, x minus 0 squared, plus I subtract the y numbers, y minus p squared. Now let's clean it up. Suggestions on how I can clean this up. This one is y plus p?
No. It was y minus negative p.
This one, we're using this p number.
Oh,
So this one's y minus negative p. For this one, I'm using this value where p is positive.
yeah,
So yes and no. Yes,
I got you.
yes, y minus minus is a plus, but you were looking at the wrong spot. So yeah, I could call that one y plus p squared. What else could I clean up? This one is just x squared. This one is 0. And then how about we take this equation and we square both sides and get rid of those two big ugly square roots? Okay. All right, so I'm going to do all that stuff. I'm going to square both sides to get rid of the big ugly square roots. This one is 0, so I don't need to write this one down. This one, as we said, this is y plus p squared equals, the big square root is gone, this one is x squared plus, this one's y minus p squared. All right, that cleaned it up quite a bit actually. Squaring both sides, getting rid of the square roots, simplifying the things we could simplify. I'm going to FOIL this one out and FOIL that one out and see what happens. When I FOIL these out, I have y squared plus 2py plus p squared, when I FOIL that out, equals x squared plus, when I FOIL this one out, I get y squared minus 2py plus p squared. I think some more stuff goes away. What goes away? I can subtract p squared on both sides. And I can subtract y squared on both sides. And then how about if I were to take this and add 2py to both sides? I would have 4py. All right, so this is our general equation of a parabola. 4py equals x squared. There's the general equation we're going to use. If p is a positive number, like I drew it here, the parabola will open upward. What's going to happen if p is a negative number? Then your focus will be down here, which means the parabola will open downward. So if p is positive, your parabola goes up. If your p is negative, your parabola goes down. What if I wanted the parabola to go sideways? Any ideas on how I could make the parabola go sideways? No? But you're close. Flip the x and y. So we could also have 4px equals y squared. So this equation is up and down, and this one will open left and right. And when do you think it'll open right, and when do you think it'll open left? Not the x, rather the p. The p, the number, will make the difference. If the p is positive, the parabola will open to the right. And if p is negative, the parabola will open to the left. Questions on that? section. I might give you (8y = x squared). Questions I might ask you: what's the vertex? What's the focus? What's the directrix? All of a sudden I can't spell that. I'll just abbreviate it. Directrix. Focus is the point. All right, so for us, the first question is very, very easy. The vertex is always going to be at the origin. So where's the vertex? Zero is at the origin. 0, 0. Always very easy. Next question I would ask myself: does this parabola open up, down, left, or right? How do you know it's up? I have x squared. When it's x squared, it's up or down. And this is positive. If this were a -8, then it would open down. P is 2. That's right. Because we need to write this in the form 4py = x squared. So P must be the number 2 because 4 times 2 will give me 8. P has to be 2. All right, so that helps me answer the next two questions. Where's the focus? 0, 2. Again, the way our parabola is going to look, it's got vertex here and it opens up. So the focus has to be up there. Focus has to be straight up, and it has to be straight up by P. So the focus is 0, 2. The directrix, on the other hand, has to be this horizontal line down here. What's the equation of that horizontal line? It would be y = -2. That's exactly correct. Y = -2. Questions on that? So, we don't really cover this in this course, but I'll give you an example where the vertex isn't 0. Let's say I gave you 12 times y minus 1 equals x plus 3 squared. You basically have the exact same properties as you do with the center of a circle. So what I'm saying is, what's this x plus 3 going to do to the vertex? It's not going to be at 0 anymore. It's going to be at -3. So here our vertex would be -3, comma, what's this y minus 1 going to do? Put it at 1. So that's what it would look like to move the vertex. We don't do that in this course. We only put the parabola, put the vertex right at the origin. Makes our lives a little easier. Math 1230, you do that? Math 1230, you talk about parabolas, but you talk about them in a different equation. So in Math 1230, you usually write your equation this way, like 3x squared plus 6x minus 5, maybe. And then, yeah, you do have to find the vertex. The vertex is not at the origin. But there's a different technique for finding the vertex for a problem like that. So. What's that? Negative b over 2a is the little formula we can use to find the vertex. All right, so how about, I'll go back to 12, I guess. Negative 12x equals y squared. What can you tell me about that parabola? It opens to the left. We notice it has a y squared, which tells us it's up or down. I'm sorry, left or right. Y squared is left or right. We notice this is a negative, so that tells us it's left. So our parabola looks roughly like this. What's the p number this time? -3, because again we have to have 4px equals y squared. That tells me p has to be -3. This time, my focus must be in there. Focus is always inside the parabola. Vertex is still 0, 0. That's easy enough. Where's the focus? 0, negative 3 would be down here. Negative 3, 0. Negative 3, 0. Our directrix is now a vertical line. Our directrix has to look like that. That's the equation x equals 3. And I remembered how to spell directrix. Okay, so you'll have some problems like that where I give you an equation and I ask you for some information. Conversely, you might have problems where I give you information and you have to give me the equation. So we're always going to have vertex at the origin. And I might tell you the focus is, say, negative 4, comma 0. If you know the vertex is at the origin, and you know the focus is at negative 4, comma 0, what does that tell you about the parabola? Up, down, left, right? Left? Down? Left. Well, we're sure it's either left or down because I gave you a negative number there, right? Left. I think it helps to draw a quick little picture. There's 0, 0. Where's negative 4, 0? Left. So the focus is here, which means the parabola has to wrap around the focus. It has to go that way. What that tells me is I need to use the equation 4px equals y squared. Left and right means I always use the equation with y squared. What's the p number? P number is negative 4. This is negative 16x equals y squared. How about if I give you vertex is 0, comma 0, and I gave you the directrix is y equals, I don't know, anybody got a number they like? 4? Y equals 4. What does this tell you about the parabola? Up, down, left, or right? Down, because our vertex would be at the origin still. Our directrix is y equals 4. Y equals 4 is a horizontal line. The parabola goes away from the directrix. So the parabola has to go down. That's when it opens down. Since it opens down, what's my equation? I'm going to start with 4py equals x squared. And then you're absolutely right, p has to be the number negative 4. Why is p negative 4? Because the directrix is 4, so the focus has to be at negative 4. The p number has to be negative 4. This one is negative 16y equals x squared. Questions on that one? One more. How about if I gave you vertex is still at 0, 0. And then this parabola goes through the points, I don't know, negative 2, 6, and 2, 6. Up, down, left, or right? Up, how do you know it's up? Just draw a picture. I think that's where I would start. I think I would start with all of these by just drawing a quick, easy little sketch. Nothing fancy. There's 0, 0. Negative 2, 6 would be here. 2, 6 would be there. So it's got to look this way. So it's got to be up. Since it's up, what's my equation? 4py equals x squared. P has got to be a positive number because it's going up. That's absolutely true. So what's P? Or how can we find P? I suppose would be a better question. I'm going to pick an X and a Y. It doesn't matter which one. I'm going to take an X and a Y and I'm going to plug them in. To make my life easier, I'm going to use this one that has all positive numbers. I'm just going to plug them in and then the only letter left will be a P. So I'm going to have 4P times 6 equals 4. That's 24. P equals 4. So P is 1/6. So my equation is 4 times 1/6 y equals x squared. Oh, I should probably simplify that. I don't know why I put a box around it. I should simplify. 4 times 1/6, that reduces to be 2/3. 2/3 y equals x squared. Looks better. But actually writing it as 4 times 1/6 isn't a bad idea, because if I leave it as 4 times 1/6, then I know what my P number is. I know where to put my focus. I know where to put my directrix. But I would probably simplify it. Questions?